Here is the classwork problem. I'm going to show you how to do it. You just follow along, write it up, and turn that in, and that will be your classwork problem. So let's read the question carefully. So it's about mean price for used cars. A manager thinks that the mean price for used cars at this particular dealership differed. So you know differed, this is a key word here, from the national mean. So you are asked to conduct a hypothesis test, and this is the alpha, this is the level of significance. So you need to compare p-value with this alpha. The first step is to state the hypothesis. So what does mu represent? Mu represents the population mean used car practice at this dealership. So the null hypothesis, the assumption is mu is 10200, 10200. And what is the researchers' belief? Because of the keyword differed, the alternative hypothesis is mu is not equal to 10200. Why? Because the manager doesn't really know whether it's bigger or smaller than. The only thing the manager cares about is whether the mu is different from the national mean. The next thing we're going to do is calculate the z-test statistic and the p-value. Let's draw a diagram first. Our sample mean is 9780. 9780. So you have this left tail. Now, because we are doing a two-tail test, because this is two-sided, so we are doing a two-sided test, or you call it two-tail test. So that means we need to look at the z curve. First, find this z value that corresponds to 9780. So I think, let me write better. This is 9780. Now, because this is a two-sided test, we need to look at the other tail as well. So this is a negative and this is positive. Okay, so we need to find these two z values. And the p-value is going to be the sum of two tails. Okay, so let's find the z first. Sigma is 1500. N is 60, because we have a sample of size 60. So typically, I like to figure out the sample standard deviation for x bar first. So this number is 193.649. So this will be your z value. Negative, because the sample mean is smaller than the mu. The sample mean is on the smaller side of mu. So the z value is negative 2.168. This negative z value goes here. So this is negative 2.168. Because we are doing a two-sided test or two-tailed test, so we going to have another z. This is the positive. Okay, so the idea is if you get a negative z, you just flip it, get rid of the sign, and you have a positive z, and then your p-value will be the sum of this left tail and right tail. So let's find out what the area is lying to the left of negative 2.168. It should be 0.015. Now, since the z graph is symmetric, the left tail area is going to be exactly the same as the right tail. So this is 0.015 for the left tail. The right tail will also be 0.015. So your p-value is the sum of the two tail probabilities. So 0.015 multiplied by 2, and you get the p-value of 0.03. This is basically 3%. 3%. Let me write it better. This is 3%. So this is your p-value. After finding our p-value, we have to compare p with alpha. Our p-value is 3%. Alpha was given to us by the question is 5%. So clearly, p is smaller than alpha. Now what's our conclusion? We reject the assumption. Why? Because remember, the p-value tells us how extreme or rare our sample mean is if the assumption were correct. And alpha is some kind of standard cutoff that we are given by the question. Sometimes 5%, sometimes 10%, sometimes 1%. You need to read the question carefully. In this question, it's 5%. So what we're saying is our sample mean is very unusual. It should not have happened if the null were true, because it was so unusual, it was so inconsistent with the null hypothesis that because of this standard that we have, we are saying that we can reject the null. We have enough evidence. Basically, we say that we have enough evidence. Okay, so we don't need to write the enough evidence here, because we're going to write a statement in plain English. Now, so let me repeat, compare p with alpha is very easy. You just compare the p-value with alpha. Which one is bigger? And which one is smaller? If p is smaller than alpha, we reject. Now, if let's say p is bigger than alpha, then we say we do not reject the null. Okay, but we don't have this situation here. Okay, so we have p smaller than alpha, we reject the null. Otherwise, if p bigger than alpha, we say we do not reject the null. Now notice that the word reject always goes with the null. We never say reject the HA. We always say reject the null. Okay, so let me erase that irrelevant part. So the next thing is we have to draw the conclusion. So this is the template. So we say, do we have enough evidence or not? We have or do not have. And then we have to write the alternative hypothesis in plain English. Because at the end of the day, what do we care about? It's not really the null hypothesis. We care about the researcher's belief. So in conclusion, we're going to write the researcher's belief as part of the sentence. So here, because we have a very small p, very unusual sample mean, so that's why we reject the null. So we say we have enough evidence to conclude. Now, so what is our conclusion? What is our alternative hypothesis? So our alternative hypothesis is mu is not equal to 10200, right? And what is mu? Mu is the population mean used car price. So let me see if I can copy this to conclude, and then I think I can type it, that the population mean used car price at a dealership is different than this phrase. Remember, this phrase is our alternative hypothesis. So let me make sure that we understand this. This part is our alternative hypothesis. So we have enough evidence to say that the alternative hypothesis is true. The hypothesis set is different, right? So not equal to means it's different. So we have enough evidence to conclude that the mu is different than 10200. And we are done. So quickly review the steps. First, state the hypothesis, calculate the test statistic and the p-value. Don't forget to double up the tail because we want the left tail and right tail. So you double up, meaning you multiply by 2. Compare p with alpha, then draw your conclusion.